Welcome to today's presentation, Managing Compliance as Code. Shift your compliance testing to the left in your software development lifecycle. Let's go ahead and get started. Jason, over to you.
Thanks, Aaron, and thanks to everyone who joined today and is interested in learning a little bit about InSpec. Just to give you, first I'll introduce myself, and then I'll give you a quick rundown of what we're going to cover in this webinar. We're scheduled to run for about an hour. We might be a little shy of that, but we will have a question and answer session at the end. So please feel free to take notes, and we'll cover questions at the end. If you do have a question that pops up, though, please feel free to go ahead and submit it in the chat, and we'll gather those questions and we'll cover them at the end. So my name is Jason. I'm Chef Federal Customer Architect. I've been with Chef since August of 2018. In my role as a customer architect, I work on government and federal accounts with a team where we drive adoption of Chef products in different federal, state, and local government agencies and solution integrators. Quick history on my background. I've been, before my time as Chef, I was a systems engineer with Tapestry Technologies, where I supported DISA for 2 years. And before that, I was with the Boeing Company in their IT organization for about 4.5 years. Also, I have a side hustle. I do work as an adjunct lecturer for the Penn State University at Mont Alto, where I teach a few undergraduate IT courses. So that's a little bit about me. Let's talk a little bit about our goals for this webinar today. So 3 main objectives I'd like to cover today are talking a little bit about InSpec and showing the value of shifting compliance to the left. And if you don't know what that means, in essence, that's taking that compliance testing and moving it all the way to the beginning of the developing life cycle, the local developer's workstation. And we'll discuss why shifting this testing to the left is so important and touch on what kind of value that you can provide through that. The other objective is to enable velocity and visibility in your application lifecycle using Chef. So we'll look specifically how Chef InSpec and other parts of the Chef toolkit, like Test Kitchen, can help you do your compliance testing locally, and how fixing these errors early can be fairly easy. That's another great thing about InSpec is its ease of use, and it's a very human readable way to define compliance. And that takes us to our last objective, which is defining compliance as code with InSpec. So is who InSpec is, and how you can actually look at a control from benchmark documentation for a compliance document. In this case, we're going to look at an unclassified, publicly available DISA STIG, and we're going to look at that and show you how you can translate a benchmark, the text in a benchmark, to an actual InSpec test, and then run that on a system. So let's go to our first slide, and let's talk about what is Chef InSpec. So Chef InSpec is what we call compliance as code. InSpec provides a language for describing security and compliance rules that can be shared between engineers, operators, and security engineers. Compliance, security, policy requirements, integration testing, smoke testing. You can define all kinds of tests as code, and then you can automate those tests and use them to run against servers, containers, cloud APIs, endpoints, and you can ensure that standards are maintained, desired state is maintained by testing the actual values for attributes on systems. And you can do that at every stage of development, which is important. So when we talk about government compliance, so one of the payoffs is that by defining compliance as code, you can do things very fast. And myself, since I work in the federal space, an important thing is, using InSpec to accelerate the process of achieving an ATO, authority to operate. And that's something that traditionally takes a long time and can be lots of manual work, things tracked on spreadsheets. And with InSpec, we can take testing and make it automated, version control it, and get that compliance auditing to be a constant thing, continuous monitoring. You may have heard the term continuous compliance. So InSpec is a big part of making that possible. So if you see here, just real quick, if you look at this slide to the right, you'll see an actual control that is defines a test for a web port, and you don't have to be an engineer to see that to see what this code is doing. So you're ensuring that a web port is listening. You get that from the title. And then there's an impact level, which is on a scale of 0.0 to 1.0, with 1.0 being the most critical impact to a system. And here you can see the actual test is a simple statement in that describe block that says port number 80 should be listening. Okay, so this is very human readable and very powerful because it is Ruby as well. So you can wrap logic around these tests. So we'll talk a little bit about the different possibilities that you get with InSpec. So you can secure infrastructure by testing the entire infrastructure for security with defined corporate and regulatory policies. And then you can prioritize issue areas based on a complete view and then remediate quickly based on the outcome of those tests. There's also security visibility. So you can create a consolidated picture of the security state and maintain an up-to-date view, enabling on-demand auditing and providing insights tailored to multiple decision makers. So InSpec is part of our solution as far as compliance and visibility in our commercial product, Chef Automate, where you can scan and see the results of tests and do a lot of powerful things that I'll cover a little bit later. But another thing that a possibility you can get with InSpec is achieving continuous security. And that's where you can automate security to eliminate risk with an up-to-date view of the status, and with the goal of rapidly detecting and correcting issues and delivering software that's secure and compliant by design. Another thing you can do with InSpec is you can detect and you can remediate things at scale. So it's some tests are simple, but even a simple test, just like checking the state of a port or checking whether a package is installed, is usually a very quick little piece of script. But when we're talking at scale, especially some big enterprises may have 10, 20, 30, 40,000 or more nodes. So to check all those nodes would be quite cumbersome unless you have an automated method to do it. And InSpec can provide that automation for you, as well as if there is a new threat that comes up in the wild, in a CVE, just knowing where the problem exists can be cumbersome. So with using InSpec, you can test the state of things at scale and find out where things need to be remediated. Yeah. So, and the last thing we'll talk about as far as possibilities with InSpec is continuous compliance. Especially in the federal space, this is important because of the Cloud Smart initiative, and there's a real effort to really to make compliance a continuous thing and not waiting till the quarterly audit or bi-yearly audit. Like we need to know the state of compliance all the time, and using parts of the Chef toolkit, that InSpec is an important part of being able to continuously monitor your compliance, so that when it comes time to audit, you can fly through the audit and have the peace of mind knowing that your infrastructure has stayed compliant the whole time, and have an auditable history of when that compliance was broken. So we'll talk a little bit about compliance as code with Chef InSpec. So there are numerous sources of compliance requirements that vary from government agencies or organizational policies. And InSpec can define and run tests on resources and assess their states to satisfy controls that are identified by such organizations as NIST or DoD or PCI or any ISO, any industry standard organizations that publish a policy that they give you either that either demand that things be set a certain way to achieve a compliance certification, or even just best practices to prevent threats. CVE mitigations. So CVEs, they present a constant challenge where you have to identify and fix new vulnerabilities on systems before attackers can take advantage. And this is something that I see in a lot of customers struggling with. It really is just a never-ending thing. Because InSpec is lightweight and it's easy to understand, and that you can really achieve speed, because when if you need to quickly create a test to test something out that's out in the wild, a new vulnerability, you can run it quickly and you can do it at scale. So imagine being able to take a new critical vulnerability and in minutes identify, one, which systems have the vulnerability present, and then two, being able to quickly write some remediation code to fix that vulnerability. It's very powerful and something that a lot of large enterprises are seeing value in. And another thing, now while let's talk a little bit about Chef provided profiles, because that's something that's part of our commercial content with Chef Automate. Is we have over 144 profiles that are out of the box. They're high quality. They're maintained by our content team, and they have automated pipelines that keep them up to date with the releases of the standards. So, for instance, I'll focus on we have many profiles for CIS, and I'll mention that right now that Chef InSpec is the only tool that is currently, to my knowledge, that is currently certified by CIS to test accounts and resources on the three major cloud providers. So we have AWS, Azure, and Google. So for a minute, talk a little bit about with Automate, cover CIS, STIG, and DevSec benchmarks, and you can then take those and you can customize them to your specific needs. And then since InSpec is Ruby, you have the power of Ruby to wrap logic around the test to fit your specific needs. So above all, what I'd like to say is that the power of InSpec is that it is code. And in today's competitive business landscape, defining everything as code is how big tech companies achieve velocity. And InSpec code can be stored in version control. It can be collaborated on with modern tools that can be used for fully automating testing with tools like Test Kitchen, and executed as part of an automated pipeline stage. So speed matters, but also testing at all stages of a pipeline matter. So getting automated testing to all stages of your pipeline pays off, because if you can move your tests all the way to the left where development begins in a local environment, fixing those errors is way less costly than fixing them at later stages, and for sure having to fix things in production. Okay, so let's move into a little demonstration here. And in this first demonstration, we'll go ahead and we'll go to the STIG viewer website, and we'll actually look at a STIG control. And it'll be for the RHEL 7 OS STIG that is published by DISA on their IASE website. So let me go ahead and share screen. But before I do that, so the basic how this demo will work, we'll review a STIG control in a web browser. We'll find a test to look at, and then we'll write some InSpec code to test that, and then we'll use Chef Workstation, which has InSpec as one of the tools included, to run that test against a system, and then we'll review the results and some of the things, the flexibility you have in reporting and such. Okay, there's a time delay there, so hopefully that screen should come up here shortly. Okay, so hopefully you can see my screen now. Okay, first let's go to the STIG viewer website. So this is a tool that allows you to view a STIG on the web, and if you look here, I've actually already drilled down to one that we can write against. But this is part of a list of I think it's several hundred controls that basically tell you what settings should be on your system to harden the system and prevent vulnerabilities. So I actually selected one. It's pretty straightforward. It's a high severity, so this is something that if this happens, if FTP protocol server package is installed on a RHEL 7, that actually puts it out of compliance. So this is considered a high severity unless you have a waiver to allow that on your system. Okay, so so here we have the rule ID, we have the severity, we have the version, and we have a description saying, look, the FTP service provides unencrypted remote access and does provide for confidentiality of for the remote session. So, this is considered a vulnerability. So if you look into details, it gives you check text, and it gives you right here a yum command that you can run to find out if the package, in this case, it's called bsftpd, if that package is installed on the system. Now, this is something simple that any person could run on the console, but again, remember that although this may be a quick test to do manually, you don't want to do it against tens of thousands of endpoints. There's the actual full package, the RPM, and then it gives you fixed text, which is actually use yum here to remove that package. Okay, so we're going to focus on here. So we see the command. We know that on a system that's the name of the package, bsftpd. So we'll now go to we'll actually go to a system. I have an AWS instance put on here, and I've preloaded Chef Workstation on it, and you can have current of Chef Workstation, which includes in there InSpec 3.6.6, which is the current stable release. So just out of here without doing anything, there's some other things you can do is we can inspect. We just hit InSpec, we can just see all the different commands that you can do with InSpec. Sorry if it's a bit of a lag. So here's just the different command line commands that you can run on here, and let's run one. Let's just run InSpec detect. Okay, and what this is going to do is this is just going to look at the box it's on. We're not pointing it at a target, although you can use SSH and hit a remote target. But here, this is just looking at the box that it's on. And we see that this is a Red Hat family Linux OS. The release number is 7.6, and we see the architecture. So let's go ahead and let's make a new, we want to code our test for the FTP package. So we're going to go ahead and we're going to make a new directory here, and we'll call it rel7.test. Okay. So we'll get into that directory. If you see, there's up in the commands there's one called inspec init. So this is a command that we can actually generate a profile with some boilerplate. So we'll go ahead and we'll do so inspec init. Inspec init. Actually, inspec init profile. FTP. Let's call it FTP test. All right, so you can see that the output showed us that the inspec created some folder structure. So let's go ahead and let's look at what that looks like. Here it created a folder structure for a profile where you have your controls, an example test put under there. It's a Ruby file, and then you have an inspec YAML file, a libraries, and a README. Okay. So for time's sake, we won't get into all the parts of this, but we can actually look at the example to see. So here we see that this is just some sample code that shows you what the structure of controls should look like. So we don't actually need that. So we can actually get rid of that. Okay, so let's look at our tree structure. Okay, so now we have it's all clean. So the first thing we're going to do is we're going to create a file, a control file. So let's go ahead and do that. And let's just call it FTP test, and make that Ruby extension. Okay, so now we're in there, and so we can go ahead and write our control here. So we can let's see. Flag in there. Control. And we'll give it a name. In this case, we'll name it for the naming convention is up to you, but using the in this case STIGs, using the number here allows you to refer to the documentation. Here, let's get this under for FTP, and this is just arbitrary, not installed. I'm not recommending this as a pattern or anything. So let's set the impact level. Remember, this was a critical, so we'll just set that as a 1.0. We'll give it a title, a human readable title, and say the FTP package must not be installed. And we'll give it a description. FTP is bad. And then we'll actually write, here's where we write our test, this describe block. Describe, and it'll be package, because that's the resource, and VSFTP. So we're going to describe, we're going to describe this package, VSFTP, and I think I forgot a D. Yes, I did. Okay, and we're going to say that it pretty straight, about straightforward as you can get. And voila, that is we've now written an InSpec test. So let's save that. Okay. And now that we've written that test, we're going to go ahead and we'll use InSpec to verify it, to make sure that it's working. So InSpec check, and then it'll be FTP test. So there, so there's no errors or warnings that pop up. So let's go ahead and let's run this with an InSpec exec command, right from the command line, InSpec exec. And then we'll just run it straight up and see what we get. And of course we get a failure because it's a demo, and failures are bound to happen. Let's see what I did wrong. So because humans are fallible and let's check that out, and probably made some sort of typo there, so we'll just paste in from. Okay, so now we see that the test ran, and sure enough, FTP was not installed, so we had a successful output. Now, and let's install FTP. So let's rerun our test. Oh, what did I do there? I'm not sure what I did there, but the before we want to think about that one, let's look at reporting, because I think it's important to talk about the flexibility. You can actually use different reporters here. So the reporter that you saw there was the CLI, but there's also a documentation, which let me move this over so we can see that. So there's different ways that you can report out. You can make it you can use JSON or YAML. So there's a lot of flexibility to how that could run. And then let's look at JSON, because that's something that's a lot of folks are interested in. So we can do JSON, and since JSON gets ugly unless you do something with it, let's look at that. So you can see that there's lots of very useful information that comes out. So it's very flexible. Okay, so let's go ahead and end that part. We'll stop sharing and we'll go back to the slide deck. And let's kind of talk about why rework is bad. So hopefully we can agree that rework is bad. And basically, since humans are involved and humans are by nature imperfect, rework is inevitable when you're producing software or doing any sort of work. So since rework is going to happen, regardless of our best efforts, let's also agree that fixing errors sooner is better. So fixing errors at the last stages or of the development cycle, or even worse, in a production deployment, can cost as much as 100 times more as fixing the error in the beginning of the life of the cycle. Rework costs can account for as much as 50% of the cost of delivering software, according to some studies. So think about that for a moment. The millions of dollars it takes to create new software, and with rework accounting for 50% or more of that cost, that can be quite disheartening for project managers and executives alike. So there's all kinds of different things that can cause rework. And on our slide here, here's some categories that came out of a university study for things that cause rework in code lifecycle. So history and versioning, not having proper tools, not having good documentation, lack of standards, or lack of traceability are some of the factors. People can be factors. Communication issues, problems articulating standards, lack of user involvement, or just a lack of skills. Requirements, changes in requirements can cause rework, untold expectations, ambiguous requirements as well can cause rework. And testing is another big one. Maybe there's not adequate testing plans, or there's no expertise, or no testers. And then another one is lack of tools. So InSpec can help solve, InSpec can't solve all of these things, but being able to provide a good testing framework and test the status systems is important in reducing rework. And then also communicating standards, because they're human readable, you can increase communication and really know like what good looks like, what are you trying to test, and why. So now now that we've looked at causes of rework, which is bad and inevitable, let's look how InSpec can revolutionize a code pipeline. So here we have a poll question. So do any of you listening, do any of you have any form of compliance testing during your local development stage of your SDLC? Let's take a few moments. I'll give you a few moments to fill it out, but yes, no, or you're not sure. Or if you don't, if you're not involved in delivering code, just in your, if you're creating infrastructure and shipping infrastructure, so creating server images or anything, do you do any local testing in your local development stage? Oh yes, I did. Okay, yeah, I did install the FTP, so that would explain that. So when we get time, I'll go back and rerun that because I installed the wrong RPM. So thanks, Carl. I'm glad you guys can see that, because when I'm trying to think and do that, easy to make a mistake. So Aaron, is that, this is my first time doing these poll questions, so I might need Aaron's help to make this one run right.
You should be good. Let's see here.
Like, do I need to answer it? Okay, there we go. Yep. All right, here we go. Yeah. So yeah, I didn't have the training, so so it looks like we're split. So about we're split pretty evenly across the board. So about a third of folks, a little more than a third of folks have automated testing. About a third don't, and a third aren't sure. So that's so to me that's like a lot of missed opportunity to reduce rework. So hopefully through this webinar and just interacting with Chef, you can look at maybe finding ways to get that local testing into your local development environments. Okay, so we're gonna look at, so here is sort of a representation of a pipeline, very simple pipeline with its stages. And before InSpec, the development phase of your common software development lifecycle flowed something like this. So over here, all the way on the left in the circle, you have dev, and that's where developers will write their code and then move that code through stages, right? And each stage would consist of gates where software quality was evaluated, or the code was run on an actual system connected to other systems to test for errors or degradations to services due to the code changes. Okay, so this is all well and good, but security oftentimes was the last or final check before accepting the code and moving code to production, and a lot of times it commonly involved a separate security team where they do an independent scan of the code, or like a system that they stand up just for the scanning, and use scanning tools to check for vulnerabilities and audit violations against some security or compliance benchmark. And then you think of all the gates that the code has to pass, and then in the final gate, if violations are found, like over here in this, after staging this security review, then the code has to be kicked all the way back to the dev side to fix the violations, and then run through the pipeline again. And if your pipeline isn't automated and everything isn't as code, this can really add a lot of this and drain resources and add cost by making the project slide. And you could say, well, if the developers had the same scanning tools used by security team, they could just do their own scans before committing the code. And I'm sure that can happen, but through my own knowledge and experience, oftentimes security usually uses a tool that the developers don't have access to or don't want access to. I think a lot of developers would maybe even push back and say, that's my job to check security. That's their job. I'm just, I'm writing features and shipping code. Okay. So if you could give, you need, along comes InSpec to the rescue to give developers a tool where they can, it's code. It's a familiar language. It can be used to define the state of the node that meets security and audit benchmarks, and then we can have those tests at the developer level and shift them all the way left, and then include those compliance tests at every stage of the pipeline. So no matter where you're at, that whether compliance is going to be affected by code changes. So we talk about failing fast and failing early. It saves money, and also allows you to, when you do that pull request, it allows you to be confident that your code is not going to break something down the chain as far as compliance goes. All right, let's talk a little bit about velocity. Okay, so in the market, whether you're government or commercial or nonprofit, velocity equals advantage, and we can let's agree that what we call the FANG companies, which are like Facebook, Amazon, Netflix, Google, they lead their respective markets in a large part due to their ability to deliver value faster than their competitors. And the way they do that is they define everything as code. They define their entire stack as code, and they use automated testing in fast pipelines that allow them to continuously deliver features, bug fixes, and enhancements. And some tech companies can deliver releases measured in hours or minutes. They're that fast, and you just don't get that kind of velocity without solid risk mitigation and testing. And that's where InSpec comes in. So unit testing, smoke testing, integration testing, compliance testing, security testing, patch validation. These are all things that can be expressed in InSpec code and can be inserted into stages of an automated pipeline. So, in this graphic here, we really want to say goodbye to the days of where we gather up a bunch of features and we wait and we do one big code push, all hands on deck. Let's wait for things to break so we can roll back, tie up everyone's weekend, and have everyone ready for, because change is risk, and a lot of risk averse organizations let's just gather up all the risk and do it one big chunk, and that's not how high velocity enterprises operate. And also rolling back is also becoming a thing of the past, because if you have that high velocity pipeline, instead of rolling back, you roll forward. You fix the code, improve the code, and then push it out. And being able to iterate quickly is important, and that's what doing everything as code gets you. So on the graphic here, we have an X and Y axis here, and so on the y-axis is the vertical. We have features delivered, which we can equate to value. And then across the bottom, we have a time scale measured in weeks. And so the blue line sort of represents your high velocity FANG type enterprise that has a 2-week release cycle, which technically isn't that fast compared to some companies. But let's say they're on a 2-week release cycle, and they take small feature blocks, so there's less risk per release, and they ship those features or fixes, so they actually provide more value sooner and with less risk. And then we have the orange company here that does an 8-week release cycle, and they do large feature blocks. There's more risk per release, and it takes a longer time to get features out to where they deliver value. So all things being equal, say this, the blue company is and the orange company are competing in the same market. They're delivering the same types of features, but the blue company delivers them faster. That's all that area underneath the blue that's not covered by the orange blocks. Who's going to win in that competition? It's going to be, more often than not, it's going to be the company that can deliver that continuously deliver those features quicker. So that's where we really look at velocity being an advantage, and InSpec can help you achieve that. So this last demonstration, we're going to look at using left, and we're going to look at a cookbook. We're going to make a change to an existing cookbook that installs Apache. And then we're going to test for compliance on the developer workstation before we would even commit code. And we're going to recognize the failure and then remediate. And then rerun the local test and show good code. And that would be the point at which you would commit to your pipeline. So let's go to the demo, and I will share screen. I'll wait for it to come up. So while it's waiting to come up, I'll just talk a little bit about what we're going to do. So we have a simple demo. We're going to switch over. If we have time, we'll go back to that other one. But here, this is just from a simple tutorial we have on our Learn Chef Rally site. This is a cookbook that installs the HTTPD package, and we can look at this in a little closer in our Visual Studio Code at what this looks like. So this is just a simple recipe that installs the HTTPD package. It starts a service and then creates a simple web page, index page. And then what's important, as far as InSpec, I've actually taken the InSpec tests, and there's a default test that came with that tests whether the root user is there and whether port 80 is listening. But here I've actually taken a small portion of some of that, some of the controls from our InSpec STIG profile that is part of our Automate product. And I've just taken for speed criticals. And one of these tests. So we just have an array of tests here. So here's this. So there's your test for VSFTPD. Okay, so that might look familiar. So that one probably will actually work. So anyway, so let's go back to the console, and we will we'll use another tool in the Chef Toolkit called Test Kitchen, and we'll actually run that cookbook on a Vagrant box. Stand up a Vagrant box. We'll run the cookbook. We'll converge the system. We'll make it do the installation of Apache, and then we'll run our compliance test to see if it meets those controls that we pulled from the STIG profile. Let's see. Clean things up before. Where am I at? Okay, now we go. So let's make sure we have a fresh Vagrant system to work on. Okay, so let's destroy that because we want to start fresh. Our kitchen destroy. So while that's run, so again, there we go. The profile, like I said, the profiles, there's over 144 in Chef Automate, and they're high quality, and they're kept very up to date with what we have, with what the CIS and DISA what they put out. So there's a lot of value because you don't have to wait a long time for those profiles to catch up with what the current benchmarks actually define. So this shouldn't take too long because we built it before. It doesn't have to download anything. So basically what we're going to do, so right now we're spinning up, and then we're going to converge our cookbook once this is done building. And then we'll use Test Kitchen. We'll then execute the InSpec test by doing a kitchen verify. And that's going to run those tests that we saw within the integration test folder. Okay, so kitchen is, so we're going to actually converge now. We're going to run that cookbook, and converge the system and install Apache. So actually, while that's cooking. All right, so back to finish. So now we're going to run a kitchen verify and actually run those InSpec tests against the system and see what happens. Okay, so you can see from the output that each of the tests that we defined, that we pulled from the InSpec STIG profile, show that right now the system is passing according to these standards. Okay, so we will do the dumb thing and we will install the package. And so, oh yeah. Oh, wait. Oh, sorry. Yeah. Yeah, let me get into the box and not do it on my Mac. Oh, kitchen login. I'm sorry. Okay, so install. Okay, so we just did something bad. Exit out of there, and then we'll run our kitchen verify again. And so test kitchen will run back through those tests. We'll see if we broke anything. Lo and behold, we broke something. Let's see. We failed a test, and oh my goodness, we failed the SV86923R3 rule, and they found the FTP package on there. Ouch. So that's bad. So imagine you're a developer and you wrote some code, and before you do that pull request with that the bad code that's going to break compliance, you catch it here in the local box, and so we can go back in, undo our mistake, and then get the system, make sure we didn't break compliance before we submit our pull request. So run our kitchen verify. And hopefully it will work. And we'll have a clean system, or a compliance system again. And there we go. So we passed all our controls, and lo and behold, we're good there. So, and I won't rerun it because we know why that failed. It's basically the same test. So I had the wrong FTP package. So anyway, that's a demonstration of how InSpec can run against the system in a local development environment, and it's very fast, very scalable. So I'm going to stop sharing here. Actually, let's see, how are we on time? We are right around that. We're going to stop for questions. So let me stop sharing the screen and go back to the deck. And so wrapping this up, so, again, we really want to talk about the value of using Chef InSpec for shifting compliance, enabling velocity and visibility in the application lifecycle, and defining compliance as code with InSpec. So let's, Aaron, if we have any questions, let's go ahead and go to the questions.
All right. Can you hear me okay?
Yes.
Great. Yeah, let's jump into some questions here. If you have any questions, feel free to send anything in right now. Obviously, we are getting close to the end of the time here, but if you have a question, we can always reach out to you after the presentation as well and follow up with you. So a question that came in here. I have not understood where InSpec falls into a Chef server / Chef client configuration so that it runs and reports. How do we integrate this into our environment, specifically when not using Chef Automate?
Okay. So, well, there's a couple different ways that you can use InSpec. You can use it from, you saw I was using it from the command line, just running Chef Workstation. You can point that at remote targets. Another way is to use Chef Automate, or well, you said not Chef Automate, but Chef Automate has a scanning function. You can also when you run the Chef client, you can have tests. You can have it execute tests and then report that data back. So there's a lot of flexibility to as well as a lot of there's going to be a lot of tools that are integrating with InSpec. I believe AWS is it Inspector or Security Inspector. There's more and more tools are embracing the InSpec language. Yeah, but if you have anything specific implementation things that you want looked at, feel free to reach out to me or to one of the other Chef folks, or speak up in the community if you're looking to implement this type of testing and maybe you don't use all the Chef kit or use only parts of the kit or use other vendor tools. So.
Great. And it looks like we got some help here too from someone on that question, saying to use a Chef audit cookbook with a wrapper doesn't need Automate server for that.
Yeah. So yeah, that's running your, you can, the audit cookbook is a great way to execute those tests. Every time Chef Client does a run, whatever interval you set, it will also run the audit profiles.
Great. Let's do one more here. We're right at time, but might be a quick one. How did you include your InSpec tests in your .kitchen.yml file?
Oh, so I can show you that real quick. So that's part of the suite. I'll just show you here. Let me share screen again. If I can get this control here to work. Oh, there we go. So if we go to, no, it's going to delay while we wait for that to show. All right, hopefully you guys can see that here. So if we go to our kitchen YAML file, and very simple, so here in the verifier, you see name is InSpec. So that tells it that the InSpec is going to be used, and then you can place your control. Your controls get placed inside this default integration. So I put it in the default so that no matter what I put in here, it's going to run. But you can actually there's ways you can do this differently. But this is a way just to make sure that it was going to run just by saying that the verifier was InSpec. But there's more material around that. If you look in our documentation around test kitchen specific, and I believe there's some blogs about it as well as this is, like I said, this is a very simple kitchen YAML file. But there are a lot of things you can do that are more complicated than what we're showing here. But yeah, again, if you're looking for help, definitely speak up in the community, or if you're allowed to share your YAML file. If you want to email me a copy of your YAML file and there's nothing sensitive in there, I'd be happy to look at it and give you any advice.
Cool. I think we will end it there. So as you can see, Jason's email is up on the screen right now, and also his LinkedIn. But thank you everybody for attending. The on-demand version should be available tomorrow, and we'll email you as soon as it's ready, and you'll be able to access it using the same audience link that you're using right now. Lastly, have you registered for ChefConf yet? We would love to see you there, so please use code SpaceNeedle19 for 10% off your pass. Alrighty, so we're going to wrap that up. Thanks again, everyone, for your time, and have a wonderful day.
Thanks, Aaron.